All right, 276. Hopefully you got a good mental break and we can honestly overload you one more time. And we're going to start here on 6.10 with the idea of global versus local variables. Now, this is another one of these instances where we have been using global and local variables. Honestly, we've been using local variables. That much is true this whole while. At its core, what happens is C++ will use and can reference a variable only insofar as it is inside of a particular statement block. So up until now, and you can see this right here on 6-16. This is on page 340. You can see this right here on lines roughly 8 through 14. I really have to squint my way down there for those. Is main, and that is what we are used to seeing. And inside of main, we are declaring a variable, int num. So main operates inside of its own statement block. So what that means is anything that operates inside of main has access to that variable, in this case called num, because everything that we have been programming to date has existed inside of main. So everything in main is accessible in main, and that works really well. Now with functions, we have blocks of code that exist outside of main. And because they are outside of the statement block that contains main, they do not have access to those variables in the same way. So in previous explanations, 6.8, for example, the only way to get data from main into one of our partner functions is to pass it there as an argument, which means that the partner functions would require those parameters. So an argument is from where I am passing it, and the parameter is what is receiving those from the function side. So what that means is if I have int num, like here, declared inside of main, it is not accessible to my partner function, which is called another function down here on line 24. So what I can do is refer to int num inside of main as a local variable. So it is local to main, and that means that it is only accessible to operations that we do inside of main. I have another local variable that is also called num, but it is a different local variable. It is local to another function, and again, that starts and stops on like 24 through 30, give me ish, 24 through 30 ish. So we have two local variables that are not the same thing, that can have different values that we can refer to by the same name in the code, but only insofar as it is local to that particular function. So I know we have been doing this a lot, and outside of the rest of this module, we will not persist in doing this. It is just like in the first couple of weeks of class, we would talk about C++ setting aside enough space for a variable with a name of num with a type of int. We're just doing that again here so you really get the hang of what is happening behind the scenes when C++ is running here. So we have the idea here that we need to add in yet of what is called scope. The scope of the variable num inside of main is the opening and the closing curly braces of main. So that is its scope. The scope, the local scope of num that exists inside of another function is only the opening and the closing curly brace inside of another function. What ends up happening is when C++ makes a call to another function from inside of main, and it does not appear that another function takes any parameters. So that means it is not receiving any data from main. What ends up happening is when we get to the line where C++ is running another function, we have a space set aside for an int called num. So that's 4 bytes set aside someplace else. C++ lets you refer to that as num. You do your work. You can see here we give a value to num, and that value is printed, but it's only printed from within the scope of another function. So the function called another function, starting here on 24 and stopping on 30-ish. So what happens at that time that C++ is done with line 28? We see the end line and the semicolon there. That means that there are no more instructions left here inside of another function. So that means that inside of normal control, so the flow of code top to bottom, left to right, in that order exclusively, C++ has to return us back to the line that called this function. So that line number is 13, and you can see it behind me here. What happens at that time is another function goes out of scope. So that means that if, which it does not, but if it had any parameters, those variables then are no longer accessible. If we have any variables declared inside of another function, those now are out of scope. We have returned from another function to main. So that means that the local variable num from inside of another function is no longer accessible. C++ will not be able to refer to that function's local variable by name, so that num is gone. The value of num, though it is true, it is still stored in that physical location, as far as C++ is concerned, is gone. So there is no way to recover that data for you if we leave the scope of another function. So now the scope is back in main. So any and all lines of code that follow, it would be line 14, let's say, for example. So if we're going to put 3 more operations in this one with, add 5 to num, display num, add 5 to num, display num, add 5 to num, display num. If we were to do that, those are all referring to the local variable inside of the scope that we're referring to, the opening and the closing curly braces for main. So that is the local variable there. So you can use the same variable name over and over and over again if it is inside of different partner functions, because C++ will not confuse which variable you are referring to, because C++ knows the scope of the operation that it is participating in. So if we are inside of main, C++ knows I'm inside of main, top to bottom, left to right, in that order exclusively. C++ maintains the flow of the program flow, so what line of code it is on. When we go to another function, C++ knows I am inside of another function, so that is local to this. Now, as a programmer, especially here as a beginning programmer, sometimes what that does is it confuses you as to which actual variable we're referring to. Are we referring to the num, so the int num variable that is inside of main, or are we referring to the int num variable that is inside of another function? That can be difficult occasionally for a beginning developer, but honestly, it has been my experience that you guys pick up on this really very quickly. So that's good news. Now, what happens if we want a variable that is accessible to any and all partner functions inside of main or outside of main that are running here within one of our applications? So instead of having local variables, what we want is a variable that is accessible globally by everything. That is, you'll notice by my leading language there, that is a global variable. A global variable exists outside of main. It exists outside of any partner functions, and it is stable as long as the program is running. So that means as I go from function to function to function in and out of scope, the values for my global variables do not change because they are they're maintained. They are available outside of the scope of every partner function. So if we come a little further down here, we will see global variables. This particular, you're not seeing the same thing I am seeing. There we go. This particular portion of the text, this is page 344 for those of you following along. We have global constants. So the idea of a global variable is that it is available to every function, main or any partner function that we would happen to create. Here, a global constant is a constant that is available to any and all functions, main or otherwise, inside of our application. So here you can see, and this is program 6-19, and again, this is on page 344. You can see up here after my includes, so lines 2, 3, and 4 are my includes for IOStream, IOManip, and namespace. Always have those in there. Next are my global constants. So these variables with these variable names and these constant values are accessible inside of main. They are accessible inside of, in this case, it looks like we have at least one other partner function. We have get base pay, and actually if we continue to scroll down, you'll see I also have get overtime pay here. So these constant rates, on line 7, I have constant double pay rate 22.5. Constant double base hours is 40. Constant double OT multiplier is 1.5. So these values, these constant global or global constant variables, have constant values, so that means we cannot change them. And please remember, if you try to change them, that will force a compilation time error. And those, pay rate, base hours, and OT multiplier, are used, or usable rather, by any and all functions that we have here inside of our application. Now, do global variables need to be constant, so fixed? No, absolutely not. If there's a reason for us to have a counter, for example, so we need to know how many times the transaction is being done, and it just makes sense to have a global constant for that. That's okay. We can have a global variable that it is not constant for that. Yeah, that's great. A counter, an accumulator, ticks upward all the while. So that's something we would have to change there. If we have, and this is just a verbal breadcrumb trail that goes to chapters 7 and beyond. If we have need for different data types than we've seen already, like an array, this is just a bonus for people who watch this video and who will watch the chapter 6 videos. Having a global array of, say, strings, for example, might be of value to you, because that way you have access to this particular data element over all of our member functions, main and otherwise. So there's always this tension there as you, the developer, are creating your applications. Realize, number one, that any and all variables that you declare are only good in the scope of where they are declared. So anything declared inside main, the scope of main is where that variable is good for. Anything outside of that, it is not accessible. In any partner functions where you define another variable, that scope of the partner function is the only place that variable is good for. The rules don't really change here just because we call them global variables. It just so happens that a global variable is defined outside of main, and it is available to all of our functions, main or otherwise.